pleasure, friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST, which has been the computer-based numerical and statistical technique that has been classed your 23rd classes of the session here. So in this we have to start with your unit 1, and as we had started with the last classes, that has been the name of the unit is your computer arithmetic, errors and roots of equation, which is of course being important one, and that what we even do have to discuss about it in detail. On the same phases, if I'm going ahead, yes, we had done your bisection method, we had done your second method, we had done regular falsy method, as well as we had done your Newton-Raphson method as well, and there are many more methods that we had done here. So we go on ahead with the discussion, and lastly we had done your computer algorithm for the bisection method and computer algorithm for the second method as well. So today we'll continue with computer algorithm for regular falsy and computer algorithm for the Newton-Raphson method, and there are many important short questions that can be asked about 2 marks important question as well, so that we will surely be dealing with it. Before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So we go ahead. So that has been write a computer algorithm for the regular falsy method. Write a computer algorithm for regular falsy method. So for that we'll deal with it, and we'll have your assumptions as well. So we talk about my assumptions. On top of assumptions, the first assumption we have here, that is being the function fx is predefined, and the second assumption we have that correct value of initial approximation 0 and x1 that are entered, in which one root of fx lies, that we have to talk about it. So we'll go ahead with the step 1, step 2 till step 8 that has been followed for the computer algorithm for the regular falsy method here. So for that, read interval x0 x1 in which root lies, in which root of fx lies, and read number of iteration to be performed. Now for the step 2 we have that is we have your step 2, which is to calculate fx is 0 is equals to fx x equals to x0 and fx1 equals to fx where x equals to n. Now for step 3 we talk about it. For the same you have to calculate the next approximation to the root x2, and that we have x2 is equals to x1 minus x1 minus x0 upon fx1 minus fx0 into fx1. Now for step 4, that is we need to calculate fx2 equals to fx x equals to x2. For step 5, if fx0 fx2 is less than 0, then root lies in x0 and x2, hence new initial approximation will be x0, which is unchanged, and x1 that 10 by x2 that changed x2 to x1. If then a root lies in x1 and x2. So hence new initial approximation will be, that is for that is been 10 by x1, change x1 to x0 and x1 then x2, which is being changed x2 to x1. Now we'll go ahead for step 6. For step 6, that you have to repeat step 2 to step 3. Step 2 to step 5, which is a step 2, step 3, step 4 and step 5, until the number of iterations are over or repeat step 2 to step 5 until x2 repeats up to given number of significant digits after decimal point. Okay, for step 7, it will be approximate value of the root is equal to x2, and in step 8 display the approximate value of root and stop. That is for the computer algorithm for the regular falsy method, which has been important and you have to know about it. That's the reason I had written each and every step here. You can just go ahead and to copy it down and you can just make it. Now we'll go ahead for the another one to write a computer algorithm for the Newton-Raphson method here. Write computer algorithm for Newton-Raphson method. And so we have, of course, the assumptions here. The first assumption we have here is that has been the function fx and its derivatives f dash x is predefined. The second is correct value of initial approximation is entered, which satisfies following equation: fx is 0, f dash double dash, which is being is 0, is greater than 0 here. These were the two conditions which we have to follow when we are going to make a computer algorithm for the Newton-Raphson method. Now we'll go ahead for the step 1 here. The step 1 we have, you have to read the initial approximation x0 and number of iteration n required. Read the initial approximation x0 and number of iterations n required. For the second step we have step 2. For that it will be, you have to calculate fx0 is equals to fx x equals to x0 and f dash x0 equals to f dash x equals to x0. For step 3, it will be, we have to find the next approximation that can be obtained. x1 equals to x0 minus fx0 upon f dash x0. Now for step 4, for the next iteration, it will be your x0, that means 10 by x1 Now we go ahead for another one, that has been the step 5, and for the same repeat step 2 to step 4. Until the given number of iteration. Or repeat step 2 to step 4 until value of roots repeats up to given number of frequent digits after decimal point. Step 6, we talk about it. Step 6. So for that step 6, it will be that what we have to talk about it. So for the step 6, it will be your approximate value of the root is x1 obtained in last iteration. And for step 7, that is to display the approximate value of roots and stop. That has been the 7 steps for Newton-Raphson method. Now further we'll discuss about the short answers question, that is of 2 marks, and which has been first important one. So we go ahead for the same. So for that, the first question that can be arise here, what do you mean by significant digit? So first we'll discuss about significant digit. So in the case of significant digit, that these are the numbers of digit that can be used with confidence. The other question that can be arise of 2 marks question paper is that which law are not valid for floating point arithmetic. So which law is not a follow for that is, we have laws are not valid for floating point arithmetic. For that we have 2 laws, distributive laws and associative law. And that is, we have your answer will be distributive law. That has been a b minus c is not equals to ab minus ac. And the other law is associative law, which is equals to a plus b minus c does not equals to a minus c plus b. The other question is, what is relative error? So what is relative error? Relative error is, it is the ratio of absolute error and a true value. Relative error equals to absolute error upon true value. And the question is, what do you mean by truncation error? What is being rounding error? What is being machine abscon? So we discuss about one by one. In truncation error, that the truncation error is generated when only required significant digit is considered and remaining are discarded. In terms of rounding error, the rounding error takes place because of the rounding the last significant digit to the nearest value. The another is machine epsilon. In that, the error introduced due to the resolutions of storing the capacity of memory or a digital computer is called machine epsilon. The another is the what is numerical instability. In terms of numerical instability, that the error goes on increasing as a recursion progress and that the answer become completely redundant. This is called the numerical instability here. Now we discuss about it, that is being the another question here, which is being write the iterative formula for finding under root capital N, where N is the real number by the Newton method. That what we have to discuss here. So we'll do the same for it. Iterative method, iterative formula for finding under root N, where N is a real number by Newton method. So for the same we go ahead here, and that what we'll find it out as well. X is equals to under root N, where x square equals to N, or x square minus N is equals to 0. Then f of x is equals to x square minus N, and fx equals to d upon f dash fx upon dx, fx which is equals to d upon dx, x square minus N which is equals to 2x. So the iterative formula for the Newton method that is to be given as xn plus 1 equals to xn minus fxn upon f dash xn. Putting the value of xn and f dash xn, will get xn plus 1 equals to xn minus xn square minus n upon 2xn here. Now write the criteria for the convergence of Newton-Raphson method. The criteria for the convergence we have, there are the two criteria. F dash x naught should not be equals to 0, and if f dash x naught is equals to 0, then the initial approximation must be changed. And for better convergence, the product fx naught and f double dash x naught should be positive. We'll go ahead with another question that has been asked. Write the formula to obtain the roots in bisection method, which is being in the interval of a comma b, that the next root is given, where we'll find out for c is equals to a plus b by 2, and that is being the formula here. And the next we talk about it, that is mean the another one is to write the formula for to obtaining the roots in second method. Xn plus 1 equals to xn minus xn minus 1 upon fxn minus fxn minus 1 and fxn here. Write an equation for the root in the Newton-Raphson method, which is xn plus 1 equals to xn minus fxn upon f dash xn. How root is fixed, a point iteration method is obtained. Function fx is expressed as x is equals to phi x, then fxn plus 1 is equals to phi xn. Which method extract the quadratic factor from a polynomial? That has been the Ling-Barstow method, extract the quadratic factor. So here we're gonna end up with this session, and we end up with unit 1 as well. In the next coming class, we'll discuss about the another that unit that has been in 24th class. We'll start discussing about the interpolations and the curve fitting. In terms of unit 1 only, that the computer arithmetic and errors, that has been divided into two, which has been the floating point number representative, numerical instability, and the errors. Floating point numbers representative has been divided into one, which has been the law of associative and distributive, and that has also been divided into one, which is absolute and relative error. In terms of error, that has been divided into two, which has been the round of errors and the truncation error. In terms of root of equation of this unit, we talk about it, that is being divided into second method, Newton-Raphson method, fixed point iteration, Attic accelerations, polynomial extraction. In polynomial extraction, that has been divided into two, which is in the Birch-White method and the Bisection method here. So we're gonna end up with here a huge request to all the viewers to please go ahead with like, share, and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this, we had done your sociology and software engineering, we had done your reasoning as well. In terms of it, in reasoning, we had done your verbal reasoning, where in that we had done in verbal reasoning we had done general mental ability in the logic reasoning. In non-verbal reasoning, we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangle, figure formation, analysis, and practice question set as well. After talking about that, yes, we had started with the quantitative aptitude. In that we had done your arithmetical ability. In that we had done operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, search and indices, percentage, profit and loss, and that has been the percentage we are profit and loss. That has been the 11th topic we are dealing here, and that has been the important one, of course, for you all. In terms of other than this, if I'm going ahead, yes, we are dealing with ER diagrams, we are dealing with ER diagrams, as well as we are dealing with your English vocabulary as well, that can enhance your English vocabulary, which will be helpful for you as well. In terms of computer based numerical and statistical technique, coming towards it, where we had started with we had completed your unit 1, which is being the name of the unit we have here. It's computer arithmetic errors. In that we had completed your floating point arithmetic, machine, epsilon, round of errors, chopping errors, truncation error, associative and distributive law of the floating point arithmetic, inherent error, error propagation, numerical instability. In root of equation, we had done your second method, Newton-Raphson method, and a fixed point iteration method for a simple root and derivative of the rate of the convergence, Attic and accelerations of conversion, modified Newton-Raphson method, and a multiple roots Birch-White method for the polynomial, Bisection method for the quadratic factor, and computer algorithm for these method as well. In unit 2, which we have your interpolations and curve fitting. In that we had to start with algorithm and the error analysis of the Lagrange and the Newton divide and differences interpolation, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, naturalist spline, Chebyshev's polynomial approximation, Lanka's economization of power series. In curve fitting, we have to cover up the linear and the non-linear least square approximation, third conditioning in the least square method, Gram-Schmidt's process of orthogonization, computer algorithm of least square curve fitting. In terms of unit 3, we have to cover up the differentiation. In that we have to cover up the method based on the interpolations and finite differences, Richardson and extrapolation. In integration, we have to cover up the errors analysis of the trapezoidal and the Simpson method. Newton, that has been the coarse integration method, Gaussian's integration method, Gauss-Legrand method, Lobato integration method, and Radau integration method, Erra-Townsend integration method as well. In terms of unit 4, we have to cover up the solution of the simultaneous linear algebraic equation. In that we have to cover up the Gauss elimination method, and then condition system, condition number, successive and over relaxative method, rate of conversions. Solutions of ordinary differential equation, we have to cover up the single step method, Range-Kutta second order, third order, fourth order method, multi-step method, and predicative corrective method as well. Statistical technique, we have to cover up the statistical hypothesis test of hypothesis type 1 and type 2 errors, level of significance test involving the normal distribution as well. So here we're going to end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.